Hello students, here we are going to solve differentiation 1.3 from class 12th. These are logarithmic differentiations. We will try to see what is the method for logarithmic differentiation. Now if this is y equal to cube root of such a big problem and we try to solve it directly, this should be written as to the power 1 by 3. Then we will have to use x raised to n formula, and in that we have to use the chain rule where there is division, then again chain rule where there is multiplication, and problem becomes very lengthy. So for such questions where there is either powers, this is cube root is power 1 by 3, product of more than two terms. If there are two terms in the product, we can directly use the product rule, u into v. But if there are more than two terms in product and division and power, then we can use logarithmic differentiation. So what we do is we write this as y equal to, this is complete bracket to the power 1 by 3, cube root is power 1 by 3, and here we write 4x minus 1 upon 2x plus 3, 5 minus 2x whole square. Now we take log on both sides. Taking log on both sides, we get log y. When we write log here, log of m raised to p will give p log m. So 1 by 3 log of 4x minus 1 upon 2x plus 3, 5 minus 2x whole square. Now we can use formulae of logarithm. Log of a upon b is log a minus log b. Log of a into b is log a plus log b, and log of m raised to p is p log m. So this 1 by 3 outside as it is, log of 4x minus 1. Now these two terms are in the denominator, so they are division. So minus log of 2x plus 3, this is again in the division, so minus, I write it here, log of 5 minus 2x whole square. Now log of m raised to p is p log m, so I can write 2 here. Is it clear? This is log y. And now we differentiate both sides with respect to x. Derivative of log is 1 upon x. In place of x we have y. So chain rule dy by dx equal to 1 by 3 constant outside the bracket. This is log. Derivative of log is 1 upon 4x minus 1, chain rule, into derivative of 4x minus 4 is 4. 4x minus 1 is 4, minus log of this derivative is 1 upon 2x plus 3 into chain rule, derivative of 2x plus 3 is 2, minus 2 times log is 1 upon 5 minus 2x, chain rule, into derivative of 5 minus 2x is minus 2. This bracket complete, and so we get dy by dx equal to, we cross multiply by y, so y upon 3 in bracket 4 upon 4x minus 1 minus 2 upon 2x plus 3 minus minus plus 4 upon 5 minus 2x, and in the last step, in place of y, we replace its given value y equal to cube root of this. So answer is 1 by 3 into cube root of 4x minus 1 upon 2x plus 3, 5 minus 2x whole square in bracket 4 upon 4x minus 1 minus 2 upon 2x plus 3 plus 4 upon 5 minus 2x. This is the final answer. I hope it is clear to you all. Let us solve the second question. Again we have product of three terms and their powers, so we have to use logarithmic differentiation. So how to solve? Taking log on both sides. If we take log on both sides, left hand side becomes log y and right hand side is log of complete term. Complete term is x square plus 3 to the power 3 by 2 into sine cube of 2x into 2 raised to x square. Now when we use formula of logarithm, log of a into b into c is log a. So log of first term, in that there is a power, so we can write 3 by 2 log of x square plus 3 plus this is log of sine 2x whole cube, that is 3 times log of sine 2x, and here we have log of 2 raised to x square, so x square log 2, this is log y. And now we differentiate both sides with respect to x. Derivative of log y is 1 upon y, chain rule, dy by dx. 3 by 2 is a constant, derivative of log is 1 upon x square plus 3, chain rule, derivative of x square is 2x plus 3 constant, derivative of log is 1 upon, in place of x we have sine 2x, so chain rule, derivative of sine 2x is cos 2x, again chain rule, into derivative of 2x is 2, plus log 2 is a constant, derivative of x square is 2x, and so we get dy by dx equal to y into first term 2 gets cancelled, 3x upon x square plus 3 plus 3 2s are 6, cos 2x upon sin 2x is cot 2x, cos upon sin is cot, and plus here we can write 2x log 2. This can also be written as x log 4. Why? This 2 can be written in the power, so 2 square can be written as 4 and the answer will be x log 4. In the last step, in place of y, we substitute that complete term and write the answer. I leave this for you. Understood this? Let us solve question number 3. Now we know all list of derivative, but there we have seen formulae like x raised to n, we can solve e raised to x and we can solve a raised to x. But this is base and index, both are functions of x. If such is the case, we have to use logarithmic differentiation, that is the only way. So how to solve? We take log on both sides, log y equal to log of log x raised to x. Log of m raised to p is p log m, so x into log of log x. And now we can differentiate both sides with respect to x. Derivative of log y is 1 upon y, chain rule, dy by dx equal to, this is u into v type, derivative of u into v is u, derivative of log x is 1 upon, in place of x we have log x, so chain rule, derivative of log x is 1 by x, this is u, derivative of v, plus v, that is log of log x, into derivative of x, that is 1. And solving this we get x cancelled, we get 1 upon log x plus log of log x. Now to find dy by dx, what we do is multiply by this y on right hand side, so we get y bracket 1 upon log x plus log of log x. Now last step, in this place of y we can substitute log x raised to x, so answer will be log x raised to x into this complete. Is this clear? Question number 4 is very similar. We have to take log on both sides because base and index are both functions of x. So taking log on both sides we get log y equal to log of sin x raised to cos x. This cos x can be written before log, so cos x log of sin x. Log of m raised to p is p log m. Derivative 1 by y dy by dx equal to, this is u into v, so cos x as it is, derivative of log is 1 upon sin x, chain rule, derivative of sin x is cos x, plus log of sin x as it is into derivative of this cos x is minus sin x. So what do we get? dy by dx, we have to multiply by this y in bracket cos square x upon sin x, this is plus into minus is minus sin x into log of sin x. And in the last step, students, we can write in place of y, we write sin x raised to cos x, and that will give the final answer. Now see this question number 5, 6, 7. They are very simple questions, but I have seen many students, brilliant students, making mistakes in solving these sums. What is the basic mistake they do over here? This is again x raised to x type, so we have to take log, that is for sure. But if we take log here in the first step, we get log y equal to log of these two terms in addition. And students, see, log of a plus b, there is no formula. The formula is log of a into b. If there is a into b, then we can use formula of log. For a plus b, there is no formula for log. So if you perform the first step as taking log on both sides, you are going to get 0 mark in the first step itself. So what should be done? We write y equal to u plus v. There are two functions. We write one as u, other as v, and so we have to write dy by dx equal to du by dx plus dv by dx. This is algebra of derivatives. Now what we have put u for? U equal to sin x raised to tan x. So let us consider now u equal to sin x raised to tan x. Now see students, this is of the type x raised to x. So taking log, we get log u equal to log of sin x raised to tan x, log of m raised to p, that tan x can be written here. Is this clear? Log m raised to p is p log m, and now derivative 1 upon u du by dx equal to u into v. Tan x, derivative of log is 1 upon, in place of x we have sin x. So chain rule, derivative of sin x is cos x plus log of sin x as it is into derivative of tan x is, what is derivative of tan x? Sec square x. Is this clear? And so we can write du by dx equal to, we cross multiply by u, in bracket we get tan x into cos upon sin is cot x, plus we write sec square x first into log of sin x. Can we simplify it further? Tan into cot is 1, and in place of u we have to write sin x raised to tan x, in bracket tan into cot is 1 plus sec square x into log of sin x. This is number 2. This is value of du by dx. So students, we have find value of du by dx separately. Now we shall find value of dv by dx separately. I write one step and then I will rub out this portion. What is v? V equal to cos x raised to x, again x raised to x type. So taking log v equal to log of cos x raised to x. X can be taken earlier, so x log cos x. We try to solve this one. Let us see what do we get. Differentiate with respect to x. So 1 upon v dv by dx equal to product rule, x, derivative of log x is 1 upon, in place of x we have cos x, chain rule derivative of cos x is minus sin x, plus log of cos x into derivative of x is 1, and so we get dv upon dx equal to v into sin upon cos is tan, so minus x tan x plus log of cos x, and then in place of v we can substitute the value of v, that is cos x raised to x, and in bracket minus x tan x plus log cos x. This is number 3. Now students, last step is for you. We know value of du by dx, we know value of dv by dx. This 2 complete and 3 complete we will replace over here, so we get dy by dx equal to this complete term plus this complete term. I hope you have understood this sum. We move on to the next sum. Again, question number 6 is addition of two terms x raised to x type. So we cannot take log directly, so we have to write y is equal to u plus v. So dy by dx equal to du by dx plus dv by dx, number 1. What is u? U is x raised to x raised to x. Now students, how do we consider this value? This is x raised to this power. Even bracket is not given. Even though the bracket is not given, we assume that bracket is over here. So this is x to the power x raised to x. So base is x and index is a function of x. So taking log u equal to log of x to the power x raised to x. And this x raised to x can be taken before log. So this is log u equal to x raised to x log x. This is product rule, derivative 1 upon u du by dx equal to x raised to x, derivative of log x is 1 upon x plus log x into, now this is derivative of x raised to x. See, we do not know this value, there is no formula in our list, we have not learned this formula. We will solve it further. How to solve derivative of x raised to x? So let us consider function z as x raised to x, taking log z equal to x log x, derivative 1 by z dz by dx equal to x, derivative of log x is 1 by x plus log x into derivative of x is 1 cross multiply by z. So dz by dx equal to 1 plus log x, and this z multiplied, so we get z bracket 1 plus log x, but in place of z we can write x raised to x. So derivative of x raised to x is equal to x raised to x bracket 1 plus log x. What we do is, in place of this derivative of x raised to x we substitute this value, and so this becomes is equal to x raised to x upon x plus log x into x raised to x bracket 1 plus log x. Is understood? Now what do we get? Next step, du by dx is equal to, we cross multiply by u, but u is x raised to x raised to x, and in bracket we have to write all these terms. Now see, from all these terms x raised to x can also be taken common from both the terms, and so we get 1 upon x plus log x bracket 1 plus log x. This is number 2. This is du by dx. Is this clear? So note this du by dx, and similarly we have to find now dv by dx. So let us solve that term now. See, what do we get? V equal to e raised to x raised to x. Now this is e to the power function of x. So we can directly write dv by dx equal to derivative of e raised to x is e raised to x, chain rule, into derivative of x raised to x. Now derivative of x raised to x we have already found it here. So it is e raised to x into x raised to x bracket 1 plus log x, and this is dv by dx number 3. This is du by dx, this is dv by dx. We use both these values in 1, and so the final answer is dy by dx equal to this complete term plus this complete term. Is this clear? Now students, last question, I leave it for you. It is of the same type of this. There are 3 functions, so we have to write u plus v plus w. dy by dx equal to du by dx plus dv by dx plus dw by dx. Solve these 3 separately and then add their derivatives to get dy by dx. So students, we stop for this topic here. Half of the topic is done. Now the next is implicit functions, that will be dealt in the next video. Students, if you have any doubt or any queries regarding this topic, you can contact on the number given in the description. Share this with your friends and subscribe the video if you have not subscribed yet. Thank you.